So, where last we left off, we made this neat little adder that, you know, that works. Don't know what else to say. Let's take a look at our to-do list here. So this, I'm still not really sure how to do that. This we can brainstorm in a second. Oh yeah, copy and paste would be nice, or even just the ability to drag stuff. Saving and loading. I mean, the other thing here, it's not really on the to-do list, but waveform viewer would be nice. Having quote-unquote analog, like in Redstone. Let me think about multi-bit buses for a second. It would be difficult to draw that. Or, well, no, not really. We could just draw whatever, but it would be hard for the user to see what the value is. For me, making the buses multi-bit is as simple as just like having a state that can be bigger. No, let's not do that today. There is another thing I could put in here that I was thinking about, like built-in mux primitive, built-in XOR primitive, because right now making muxes or making XORs is really a hassle. You need at least 3 gates, and like the point of this simulator is to be like a fun little thing to play with. It's not really meant to be like, if I wanted this to be hardcore, you know, I would have only given the user a NOR gate and said, there you go, have fun. Yeah, so we could do that. Where would I even put them in the component menu? I guess I could put them next to the I/O. Now, I think it's possible to make XOR from mux. I'm pretty sure. So, I mean, you can couldn't tell because it's a live stream, but it's really early, and maybe it was a little ambitious of me to think I could work on this, or I didn't sleep well yesterday. Anyway, so we did this. Is today the day we do the save and load? Let's think about loading for a second. I think I wrote down some notes to myself at some point. Yeah. Where would I have put that? So for loading, I think the thing to do is to first scan in all of the gates and then do a second pass and do the nets. Excuse me. Now, when we're scanning in gates, okay, I have an idea. Just make a new tab here. Save load function. I guess we will do scan tiles or something. Excuse me. Man. Oh, geez, I don't even know where to start with this. Like, if we had something like this, for example, we would do a first pass, skip the nets for now. We'd see a junction, a gate. We know what its negator state is and all of that from... okay. One thing I can do is I can do like a debug thing right now and bring this up incrementally, where what I'll do is I'll just have it scan the thing under the cursor and print out some stuff in the debug window, and then I can use that to bring it up. So what I need to do, I need to say what kind of element it is, whether it is a junction, a gate, a reg, or an IO. I need to interpret its state. I need the t off, which is free because we already have it. Wait, no, that's not true. It's not free because we get the tile ID, but the associated t off is the, over here. Yeah, and then for the nets, it's a lot more complicated. We have two options. Either we just scan through and add to the nets as we see net objects, or like wire types, wire objects. Or we do like a DFS, so we'll find a net and then follow it with DFS. I think DFS makes more sense for the nets, because otherwise you'd have to like have a table of like incomplete nets. Like, let's say you had already scanned up to this row here, you would need to remember that you have two nets, one of them which has a downward facing connection into here, one of them which has a downward connection facing into here. Or wait, do you need to do that? Because let's say we've scanned all the way up to here, then we scan here and we say, oh, well, this one has an upward connection, so if there is a net sitting above it, connect to it. Yeah, and then here the same thing, there's a leftward, if there's something to the left, connect, if there's something to the right. Well, because we're scanning left to right, top to bottom, we don't ever have to check down and right connections. Then we keep doing that. This is a junction. Oh, no, we do need to check right connections because we could have components. Right and down, yeah. So if we go to the right and we see that it's a component, we connect to the given port. Yeah. And so then we just need to know, given the tile ID, what directions are connected. Oh man, this is tricky business. Yeah. Well, I have about an hour and a half, give or take. If I can just overcome my mental inertia here, I can get started on it. I don't know if I'll be able to finish it. What else do I have in here? Whoa, what is this? This is a summer circuit for a full adder, and it's pipelined and everything. Anyway, yeah, so I think that's the right move here is, well, do we need to scan all the gates ahead of time? Problem is, scanning left to right, top to bottom, is really inefficient because we'd have to scan every single block, but our grid, well, actually that's not, we do have to scan every single block, don't we? Because we don't have the grid object anymore. So actually, yeah, we do need to scan every block. So let's well, I mean, there's no choice here. What we need here is a lookup table. So this is tinfo, I'll call it. And this is just going to be a big lookup table. I mean, there's really no other choice. Actually, there is another choice, which is I can generate it instead of me manually typing out every single row. I can at least generate it with some for loops, which would be a little bit nicer. Yeah. Okay, let's do that. So, so first thing we'll do is junctions. Oh my God. Man. So what does the state of a junction look like? It's just got the two nets in it. Oh, interesting. Actually, we don't need to interpret the state from the junction because when we connect it to the net, that'll happen for free. Okay, we need the junction type. Equals 2 to 5. Tinfo of I equals type equals junction type. 0, and I think that's all we need. And we can do the same thing for this. I never use abutting junctions. I'm not even really sure it was worth the trouble to put them in. I don't even know if they work, actually. Okay. Now we'll do IOs. Okay. Now for the gates. '48 through '63. And we need the T off, don't we? How does this work? T off is just equal to 2 for this one, and T off is equal to 6 for that one, I think. We need the T off, right? Maybe we don't need it for the junctions. I don't think we need it for the junctions, but we do need it for the gates and the registers. So this is not needed. Equal to 48. Oh, wait. No, it is actually just equal to I. Go figure. So I guess here we use the states to, yeah. Maybe that is all we need. Now for the lookup value base, oh, here we subtract. I think I need to do I minus 48. Or something. Yeah, this is done in a really weird way. As for the lookup value base, so wait, hold on, I need to think about this for a second. When I read the stuff, when I parse the gates, I'm gonna create like gate objects. I think it would be better if I call the actual like place component function Uh, oh, shoot. But we have this to worry about. Shoot. Well, actually, no, we can call the place obj function, because this creates all the ports and everything. It does the auto connect, which apparently doesn't work in all cases. So yeah, we can use this object that, well, junctions are a different story. We'll deal with that, but here's a thought. What if yeah, we'll just call, so the idea here is if we're scanning along and we see this, for example, and we see this, for example, then we will call place wire three times. One here, one here, one there. And then we don't have to worry about yeah. Okay, I think I like that. So whenever we do still need to do junctions first. We definitely want to do the gates first, because if you do the gates second, it'll erase the square and disconnect the adjacent wires. So we definitely want to do components first. Yeah, okay. And let's carry on with what we're doing, because I think it'll work. The only thing is that so for yeah, so for the component types, the IOs, the gates, and the regs, we'll actually build the whole object here. We'll have to decopy it, obviously, but that's okay. And then we'll call place obj. For the junctions, we'll call it place junction, yeah. So we do need to put in the lookup value base stuff, which is fine because that's okay. Yeah, so when we scan the gate, that's when we'll find the coordinates. So we need to leave that off for now. So we need the lookup value base and the LUT. And we already have the state, so yeah, fine. yeah, one indexing. So got that, got that, got that, got that, got that. Oh wait, do we got this? Ah, yeah. I see. Like that. Okay, and then finally, reges, which is one of the trickier ones to do. Oh man. Okay, well, yeah, this is cumbersome because we gotta do the 2-bit ones, the 1-bit ones, the 3-bit ones. And we don't need to care about this row here because, yeah. So we only need to do this up here. All right, fine. So length equals 1, 80 to 81. T-info of I is equal to type equals reg. T off equals 80, I think. Right? So, okay, I think the reason is because I picked the ones, that's right, I remember now, yeah, in the component menu, I wanted to show these to kind of imply to the user that you can connect to the top and bottom, because unless there's something already connected to the top and bottom, you'll just see this when you place it. So this is just meant to be a hint. So yeah, that's where that minus 16 comes from. And the lookup value base is, yeah, so I have this register lookup table is actually 3 64 entry lookup tables all smushed next to one another. So yeah, so here the lookup value base is just going to be 1. So lookup value base is 1. Lookup table equals reg lut, and state is 0. Now we do the other one for state equals 1. Oh, no, what am I doing? This is still state, this is I minus 80. But then this is I plus 16, because the difference between these is whether it's latched or not. Okay, and now we do the same thing for len equals 2. So this is 82 through 85. T off is 82. And this is I minus 82. And the lookup value base is 65. And then for length 3, we have 86 through to 93. This is minus 86, 129, 86, 86. Done. So now, this T info, well, we may as well put in the nets while we're at it, which is going to be a little bit different, but for I equals 16 through 31. Now, I really wish I'd done the connections in binary order, so I wouldn't need to remember how to use my lookup tables. But anyway, T info of I is equal to type equals net. And here, I'm actually not going to, because I'm just going to call place wire. So all I need to know is the connected directions. So whatever, man. Let's just do it like this. Local direction. Or I guess like connected directions is equal to, and I'm just gonna do this the dumb way. I'm just gonna save the deltas. So this is 1. This is GW. This is -1. Minus GW. Now here it's 1 in GW. GW and -1. -1 and minus GW. And minus GW and 1. This is like unreadable, but I kind of don't care right now. So this is now, okay, so we did these, now we did these, now we need to do these. So this is minus GW, 1, GW, 1, GW, -1. GW -1 minus GW -1 minus GW 1. Okay, it spills off the side, but that is okay. Then we have these guys, which is minus GW and GW, and then -1 and 1. then finally all of them. 1 GW minus 1 minus GW. And ders is equal to connected ders of I minus 16. 15 because of the 1 indexing. And the same thing up here, which is I plus 16, because we need to do both of these. And I think that is it. Yeah, that's it. For these, we may as well. Yeah, okay, so let's go in here into the init function and call gentinfo. Generate lookup table for loading saved tile data. Let's see if we have any errors. Of course we do. Oh, I forgot to do. Okay. No errors, so that's good. Now for scan tiles, let's do, we need to actually give it the thing to scan. So our rule will be, before calling scan, we're always going to put it in the map. So we'll have an initial x, initial y, distance in x, and distance in y. Or we'll just call it end x and end y. Yeah. Put in default values. By default, we'll just do the whole entire map. Oh, one more thing. Part of our ugly hack to squeeze more info into the tile data. I is equal to 128 up to 255. T-info of I is equal to T-info of I minus 128. Okay, ex4. How big is the map? I think it's 127 for the max. Then local EY is equal to EY or 63, I think. Now, I mean, there's no choice. We just got to iterate over the whole thing. I mean, should we do this with a deadline? No, let's not do that. So, yeah, for I equals x through to ex. Actually, I prefer to have y on on the outside for whatever reason. And for j equals x, leave it x. And what I will also do is like that, just so that we don't need to prevent needing explicit nil x. And yeah, so we will do local ti for tinfo is equal to, oh no, actually first let's do local tino equals mget ij. Is that how mget works? Yes. Oh, but it's xy for whatever reason. Ji is equal to tinfo of tino. So now if component, then place the component. Let's just go ahead and save ourselves a little bit of trouble here, and let's just also do like is component equals true. One thing I've been meaning to do, which I just thought of now, is let me take this deep copy stuff and put it into the helpers, because that's where it should be. I love how colorful this is. This is the code editor. It's just a random thought, but anyway. Yeah, so that goes in there. Is there anything else I can put in the helpers? I mean, I almost need a whole tab just for lookup values. You know what? Let's do that. There's going to be a little bit of a pain here. Oh, wait, actually. Moving stuff between tiles is a little bit miserable, but it's okay. I don't have to do it that much. So I just copied sound effects names. Now save and load can be the last one. I don't really care. Well, actually, no. I can just get rid of this. Except I can't. Okay, 1 second. Okay, so we swapped save and load with sound effects names. Sound effects names, I'm okay with having it at the end here. Actually, when I say I want it at the end, I want the notes and the sound effect names to be at the end. So I actually think I will just put this in the notes just to save a tab here. Okay, save and load. Okay, notes at the end, save and load. So now I want to make a new tab. Oh, I can get rid of this, right? Yes. Now what do I want to put here? Oh, no, wait, hold on. Save and load did need to go there. This needs to become... I see, yeah. So this copy of save load needs to become data structure management. Okay, this copy of data structure management needs to become the drawing functions. It's really a pain to move stuff between tabs, but it's okay. Helper functions will now go here. And finally, we can use this to be lookup tables. We can dump all of this stuff. We'll put a few more things in here as well. Like all of this. Hope this doesn't break anything. I may as well leave this here. It's not hurting anybody. This I may as well leave here. So 522 lines, that's a bit better. Man, I almost want to put the undo stuff in its own tab. Now, let's see if we broke anything. No, it still seems okay. Okay. This is something I've been meaning to do, because I just want to put this inside debug.p8, this log stuff. So let's just do that. I'll need to do that in my editor. Okay. And then the other thing I need is that? Is that in the draw function? Maybe it's all the way down in the debug stuff. Oh yeah, here we go. I'll just put this at the top of print debug. And I guess we could put it inside debug enable because there's no point here in forget how to use the block cursor in Vim, so you'll just have to tolerate me doing it like this. And one last thing, it is useful to be able to crank up the log size. So we will do log size is equal to 50, and then we can change this. Alright, now let's see if we broke anything. Yeah, I think it's fine. Yeah, I've been wanting to move that into the debug here. Yeah. So that I can use this in other projects. Okay. Maybe this was the right thing to do, is just like work on cleaning up the code. Drawing functions is pretty small, so we can put some stuff in here. So we've got the draw G menu. Let me see what's in between. So we could make this a function. Okay, did that break anything? No, seems fine. Okay. What is this? Oh, the helper stub. Oh, what is this? Fine, whatever, we'll just keep that. So, in the helper function draw helper stub. We'll see what arguments it needs. If mode equals 1 and we're not single stepping, then we do all of this. What is CL? Okay. You know, just pass it right in. right. Okay. What time is it? Oh, man, what? How long have I... How can it be... How long have I been on here? I've only been on for an hour. Oh. Oh, wait a minute. Was today the time change? I don't know what to search. Did the time change last night? Daylight savings time begins on Sunday, March 13th. What? Okay, Sunday, November 6th, 1 a.m. local time. Yeah, it was today. Okay, I got scared for a second because I need to go at 7:45. And I was scared. Okay. For the cursor, I don't really want to make that a function. Yeah, that seems good. That seems good. Okay, I'm happy with the draw function. The update function is an absolute garbage fire. Well, I'll look at that in a second. Let me see if there's any other like easy stuff. Init function's fine. Yeah, these are okay to have in here. Now the do, undo, and the start snapshot and all that stuff could be its own tab for an undo stack. Set speed is fine to have in here. Alright, let's put the undo stack in its own tab, for better or for worse. But we'll keep the globals in here for consistency, I guess. Okay, now did we break anything? I don't know, seems fine to me. Okay. This is some very much needed housekeeping. It was getting to be really annoying to move around in here. It's fine to have this in here. I guess I could tidy this up a little bit. Also, this log function is not necessary anymore. This is working fine, and it's just bothering me. The modes. Yeah. Okay, that's fine. So the last thing to do is the update function, which is an absolute, like, just it's just chaotic. This I think is okay. Oh. This actually is not right. I think we have this gated off in the draw function anyway. Yeah, that's fine. That's fine. So if undo mode, this is okay. This is okay. This is fine. This could be its own function. This could be its own function. But honestly, I don't think it would clean anything up to move any of these to their own functions. Yeah. Here's something interesting. Actually, we should run this once. Hope that doesn't break anything. Yeah, I think that's fine. Okay, I'm happy with this. I'm actually kind of finding this therapeutic here, is just reading through the code and just cleaning stuff up as I see opportunities. Because I could put the movement lookup table in here, but it's fine. Oh my goodness, the DFS. This DFS got out of control. I kind of don't want to touch it. Fine, let's look at it. Find all coordinates reachable from linear coordinate L belonging to net N. Returns CPJ, where C is a list of coords belonging to N, P is a list of ports connected to N, J is a list of junction net table object thingies. Another hack, if N list is given, then use N list as the neighbors to traverse. Otherwise, just check all neighbors. Oh man. I don't know if there's any way to deal with this other than to rewrite it from scratch and just redo everything. post condition, I don't care about cleaning that up because eventually I'm just going to delete it when I'm done. Dump nets. Okay, so for post condition and dump nets, I don't need to touch those. Update nets is pretty good. Update state is pretty good. Syntax is fine. I don't even think I'm using this right now. These deep copy functions are fine. And this is fine, that's fine. So really the only like stinky thing in here is DFS. And I don't want to touch that right now, or ever. Now let's take a look at these. These are probably fine too. Yeah, that's all right. You know, I think it's fine. I don't think it can make it any cleaner. Well, that's not true. Like, I could put in like member functions and all of the objects and have it like do virtual dispatch to the function pointer inside the object and make the general functions look nice and clean. But I don't want to do that. Okay, so sue me. Yeah, okay. Draw G menu's fine. Is that all I have in here? I thought I had more. Wait a sec. I think I put these into the wrong. Oh yeah, these are in the wrong place. Everything in the wrong place. Okay. Out there. Still okay? Yeah, I think we're still okay. What else? Oh my goodness. This is like the most hideous code I've ever written. I also don't know any way to like simplify this. There's just a lot of corner cases in this code, like, you know. I mean, it would be a lot shorter if I took out all the log calls, but I don't want to do that right now because I'm sure I'll have more stuff to debug as time goes on. Actually, everything except for place wire is pretty okay. Actually, so it's really just place wire. Save and load I'm in the middle of doing in the first place. Undo stack is pretty much fine. Yeah, and then nodes is nodes. So. All right, let's push this. Okay. I gotta get used now to where all the tabs are. Okay. Now. Man, I'm trying to get over my mental inertia to working on this because it's like, you know. Okay, we have our T info. If it's a component, then place the component. Okay, fine. Oh yeah, I remember now. I got distracted. So I put is component equals true. Let's do that. I started doing that and got distracted. Okay. So now we can go in here and do if ti.isComponent. We need to make a deep copy. Come on. And I think we can just do, oh, but we need the linear coordinate. Equals I times GW plus J. Or do we? What do we need to, what do we have for place component or place object? Oh, it is CXCY. Yeah, I think that's it. I think that's all we need. So actually I don't need that. Place object JIO. If component, then place the component. Else if ti.type equals junction, then if junction is, well, actually I can write this more succinctly. If component for junction, then place it. O type equals, so this here I can kind of steal from, I'm used to stuff being in certain places. This is going to drive me crazy for the next little while. Oh, I guess place junction is a whole separate ball game. Oh, I don't need to do that. I see. So, I just need CXCY and the type. So, place a junction, CXCY and ti.jt. And then we do it all again. First pass, deal with components. Now here's something else I want to do. OX, OY equals OX, X. Y. This is just a hack. I'll write it down anyway, but OX, OY, a hack for initial testing adds an offset to where tiles are placed in grid. So actually here I want to do plus OX plus OY. And now we can test this out, which is really, really slick because, I mean, check this out, right? So we're going to go in here. This is, I mean, Pico 8 is really nice to work with in a lot of ways. So, let's just do a quick, little design or something. And, oops. And just for good measure, let's put in a junction. try and test some stuff out here. So now I think what I can do is I can go in here and I can do scan tiles 0, 0. Let's do 15, 15. Let's do an offset X of 16, 16. Fingers crossed. Attempt to call scan tile. What is it called? Oh, scan tiles. Oh, great. Man, Pico 8 is really nice to work with sometimes. Well, most of the time. Okay, great. No, not great. Attempt to perform arithmetic on... Oh, I forgot the coordinate. I forgot the coordinate. So, let's just go ahead and deep copy it here. Well, there's no need. I can just do O dot C is equal to... Now, hold on a minute. Why do I need to do that? I shouldn't have to do that. I shouldn't have to do that. I might not even need L. I should have copied it. So now what we can do is we can go up here and place object, and we will do O.C equals L. So let's draw that same little tester circuit again. You know, why not? Let's put in an abutting junction. I never do that anyway. Oh no! Okay, hold on. I'm not here to fix that right now. I'm here to do something else. So we'll deal with that when the time comes. There's really no need for me to draw a specific circuit here. We still have bugs. Still have bugs. Okay. So you think that's still in my history? Oh, nice. Okay. Ugh. Come on. Nil value. Why is that nil? I don't understand. Why is that nil? Shouldn't be nil. Where is this error coming from? In the post condition. Oh. I wonder if this is a situation because, yeah. I wonder if this is because when I hit escape, it just pauses it at some arbitrary time. Okay, in that case, let's not do it with the command. Let's just hook up a, a button to do it. Oh, we can do this with a menu item actually, which I think is the right call. Menu item 3 test scan or something. Scan tiles of 0, 0, 15, 15, 16, 16. Okay. Well, let's just do it now with an empty. Okay. So nothing happened. Okay. Now let's just try a single component. Oh boy. Attempts to perform arithmetic on field C, a nil value. Okay, let's check out this place component, look at it more carefully. So we make this object. I'm making the exact same object as far as I know from scan tiles, and then we just call place obj, and that's it. I don't understand. How come this works? And okay, well, let's check it more carefully. So if it is a gate, we create an object with all this stuff, and we do place obj. Oh. No, it should still be fine because I'm. That's weird. I think that's probably the issue I was having. Just like a half-written line of code. Oh no, but it didn't work. Maybe it went down here. Oh no, I did 16 and 16, didn't I? So it's actually diagonal. Hey! Oh, look at that. Okay, hold on. Let's, instead of 16, 16, I want 16, 0. And actually, let's just make things easier on ourselves and even just do like 8, 0. No, let's do 0, 8. That's more interesting. We'll just keep it small here. So all right, moment of truth. T off. So somewhere I'm not setting the T off. I'm setting it here for all the registers. I'm setting it for the gates. Oh, I didn't set it for the IOs. Okay. 11. Oops. It didn't get the junction though. How come it didn't get the junction? If is component, do that. Otherwise, if the type is junction, then do that. Type equals junction, junction type equals 0. This should work. So why doesn't it? Forgive me. Sorry. It should be going in here. Let's put in some log statements here. Log, found, junction. Okay, do that, go in here. It did find the junction. So how come it didn't do anything? Place junction. Erase whatever was there. Oh, the junction type is wrong. Okay, what are we giving it for the junction type? J. Oh. Oh. Weird. That's really weird. But it's fine. I can just do this. So the JT here is actually 2, and the J here I think is actually 6, which is bizarre. This should work now. Okay, great. So step 1 done. Now for step 2. For dnti.dirs do this is not the first pass, this is the second pass. What time is it? Okay, I still have 45 minutes. Right? Yeah. Second pass, deal with that. Now, this is really ugly, but reset LWX and LWY to prevent unexpected connections. So we'll just do LWY equals minus 100 or something. And now we can do, oh man. Oh no, shoot, the place wire function takes x and y, doesn't it? And of course it does. And I did all my directions as linear offsets. Maybe I have a lookup table for this, which is like, no, I don't. Oh, yes, I do. Well, I kind of do. Whatever. I just, let's just. Local blah. Local dx let. Oh, wait a minute. I can do a little bit better than that. Wait, can I? I forget how mod works for negative numbers. Whatever, let's just do this. This is simpler. This is just simpler. And I'll just put a to do here, which is to do make this more clean this up. And then for the dy let, it's just going to be like this. Dx equals dx let of d. Now we will do place wire at j plus ox, I plus oy, place wire j plus ox plus dx, I plus oy plus dy. And that's it. That's the whole thing. Assuming it works. So let's just try this. Oh boy. Oh, I need the pairs. I pairs actually. Alright, we can do all. No dice. I see. Interesting. Okay, so far so good. Yo, did we do it? Was it easier than I thought? Oh, interesting. It doesn't erase what was there before, but that is okay because when we implement copy and paste, we'll clear out the map in the area that we're pasting. Okay, let's do our little tester circuit there. they're in perfect sync, I think, because we copied the states and everything. No, this one is one cycle behind, which I guess makes sense. I don't know. I don't really care that much. Yeah. Yeah. Wow, cool. I can't believe that works. All right, let's push this. There's still that abutting junction problem that we need to fix. So let's just push this for now. Alright, let's see if I can recreate that abutting. I don't even think I've tried abutting junctions, like... Whoa, oh, wow, it happens pretty easily. Whoa, okay, can I make it happen even easier? Oops. Okay, that's okay. That's also okay. I think it happens when it's connected to itself. No, that didn't cause any errors anyway. Maybe it has to be... I feel like this is a problem I've had before. Start of... Oh yeah. Junction 1 to the right connects to an unlisted net. Num nets equals 3. Okay, let's turn on the net dump so we can see what's going on. Oops. Wait a minute, how come that connected? How come that connected? Oh, fascinating. Very fascinating. Okay. So now if I erase this, what do we have in the log? I just have erase square. Net 1. 3, 2. 0, 1, 2, 3, 0, 1, 2. Net 1, 3, 2. Net 2, 4, 2. Net 3, 0, 1, 2, 3, 1. How come there isn't another net on this junction? Oh man. And also junction 1 to the right points to an unlisted net. Oh, I get it. That net 1 for 3, 2 is the second net on the junction that we never hooked up to anything. Okay. Alright, we'll probably need to add a few log statements. So let's put a separator in the log. I have a feeling this isn't going to be too helpful. Did not delete last chord of net. Found net neighbor. I can't read this. Don't remember what this means. Add forestry to the chord list. DFS at forestry. Neighbor 3 is junction. Hold on a minute. Does this happen? I don't know if I've even tried this case here where it connects back into itself. This seems to work. Oh man. Neighbor 3 is junction. If grid, if o.net, o equals grid. Oh my goodness, I forget what all these variable names are. What is NL? Where is that getting assigned? Oh, here we go. New L. So for D in all neighbor list, do. So the new L is, or the neighbor, I get it, neighbor linear coordinate is L plus D. If grid of an L type is equals junction, O is equal to the particular port. I don't understand this penum here. Maybe this penum is wrong, but I don't understand how it could be wrong if it works for the abutting junctions. Oh. I think I know what the problem is. It just so happens that with the flyover junctions, if we have the wrong direction, it'll still end up being right. Because they go in a straight line. So actually, I think this penum is wrong. I did have some trouble with penum. Penum let of minus D. How do we do this for gates? Local penum let of D. Port grid of an L. I'm so confused. And this code is just spaghetti, dude. Like, now, here we have penum let of minus D. And the point of this is to get the neighbor on the new guy. Or is it? I gotta check the comment on that. Given self-linear chord minus neighbor linear chord, return what port number it is on the self. Okay. Oh, I lost my place. Where is that? I was in DFS. Okay, yeah. So here, our current coordinate is L. DFS at why is everything empty? Hold on. Oh, because I did the other one, yeah. Okay. DFS at 3, 2, 0, 1, 2, 3, 0, 1, 2. DFS at 3, 2. Neighbor 3 is junction. Now that is correct, but actually that 3 just doesn't, yeah, I think I need to clean up what's going on with this penum here. So NL is the new linear coordinate, therefore the distance to it is D. That means the distance, okay, so let's do this. Let's not be afraid. This is the penum on self. And I'm actually going to name it that as such. Okay. Neighbor blah is net. Also is component. Penum self, and now penum G. What? But how is this working before? D is the distance. D is the distance from us to the gate, which means we would have to negate it to get the distance from the gate to us. And therefore, this should be minus D. Okay. I think when I needed to fix this minus sign, I think I fixed it in the wrong place. I think that's the issue here. Else if junction penum self, and then here we will do penum J. Neighbors J. I think we need penum J. It may or may not matter, but let's do that. First, let's start with something that should already be working. Okay. Oh, no, it's still broken. Hold on, let me put this at the same place that it was before. Okay, DFS at, oh, 42, I wanted 3, 2, 0, 1, 2, 3. DFS at 3, 2. Neighbor 1 is junction. No, it's not. It's neighbor 3. What is going on? Oh. Penum self. So if self minus neighbor, oh, wait a minute, wait. It's self minus neighbor, which means that actually this does need to be minus D, right? Because NL is L plus D, so N minus NL is negative D. Whew, okay, and this needs to be that, and then this needs to be that. I don't understand how that other case worked, but first let's see if we fixed this. Okay, great. It has a little bit of weird behavior, but I honestly just don't care. Let's just try some other stuff. Make sure that we didn't break anything else. No! Shoot. It still didn't fix it? Oh my god. We fixed it for this other one. We didn't fix it for that? Oh, God. Why? I think we just broke it. I think that used to work, that hourglass case I just tried. I think that used to work. I'm trying to create a simpler test case. Okay, so it has to do, I think I broke somehow this lookup here for the neighbors. Neighbor list, so neighbors J. Let's go take a look at that neighbors J. I think these are maybe backwards, port 2, port 3. Okay, so that fixes one thing, I think. Let me just double check there with that hourglass case from earlier. Yeah, okay. Okay, so that fixes that at least, but we still have a problem with this, which happens when both of the nets are connected together. But somehow this is okay too. Oh, man, this is weird. What's the issue here? Grid connects to an unlisted net. let's do an hourglass case first. I mean, I think there is something a little bit wrong with the neighbors. Because in this case here, if I erase this, I expect this to stay connected. So let's double check the neighbors again. So for type 6, port 1 should connect down, port 2 should connect to the right. Yeah, this seems fine. Port 3 should connect up, and port 4 should connect to the left. I think this is fine. Alright, let's walk through the DFS there and see if we can understand why. In the DFS, so we first do a DFS at 2, 3, 0, 1, 2, 0, 1, 2, 3. DFS at 2, 3. Neighbor 4 is junction, that's correct. Junction connected, keep DFSing. DFS at 2, 2. DFS returned 1 junctions. Two, 2. What? Huh? So we have a DFS at 2, 3. Neighbor 4 is junction. Junction connected, keep DFSing. DFS at 2, 2. Oh, right, 0, 1, 2, 0, 1, 2. Okay. DFS at 2, 2. And then it just stops there, but I don't think it should. DFS at 2, 2. So for the neighbor list, for D and all neighbor list, let's assume for the sake of argument, well, okay, let's just do log testing neighbor D. Yeah, and testing neighbor 1. We should be testing neighbor -1. What the heck? Do I just not understand what's going on here? If we come in on port 1, we should go to port -1. If we come in on port 1, oh, whoops. We come in on port 2. Oh yeah, actually I think this was right in the first place. So that should at least fix this case. Okay, good. Now does it happen to fix the case where both nets connect to one another? Oh, not quite. I want a simpler test case. Whoa. Junction 1 to the right to an unlisted net. DFS at 2, 3. 0, 1, 2, 0, 1, 2, 3. Okay, that's correct. Testing neighbor 1. Neighbor 1 is junction. Junction is connected. Keep DFSing. DFS at 3, 3. Why is it testing all 4 neighbors? Why is that happening? Junction connected, keep DFSing. Neighbor list is equal to neighbors j o dot parent dot jt. I have a feeling that this just isn't working. Log and list 1 equals try and recreate that test case if I can. List 1 equals 129. So why is it testing all 4 neighbors? Neighbors j of something something. Neighbors j of something something. It's just a single number, presumably. In fact, was it 129 or minus 129? It was 129. Actually, I think that might be right. Port 3. Yeah, I think that might be right. So, okay, let's assume this end list is right for a second. I mean, we don't have to assume. We can actually just do this and double check that the second element is nil. So weird. Junction is connected, keep DFSing. So why is that happening? The neighbor list is correct, so we don't need these anymore. Oh, we even had an assert statement here. So the neighbor list is correct. So then we call DFS again with 1, 2, 3, 4, 5, 6, 7 arguments. 1, 2, 3, 4, 5, 6, 7 arguments. Neighbor list is equal to neighbor list or neighbors. Also, I want to quickly see if I can create this test case in a simpler way. It might be enough to just do that. No, it's not. Don't ask me why. so strange. I mean, what a strange error. Like, I don't understand, but... why is it testing all 4 neighbors? What? I don't get it. DFS at 3, 4. Did I? Oh, I did put it in the wrong place. 0, 1, 2, 3, 0, 1, 2, 3, 4. DFS at 3, 4. But I don't understand why it's testing all 4 neighbors. What? What? This doesn't make any sense. I don't understand. Why is it testing 129 twice? What? What? Whoops. If you're wondering why I'm always going to the same spot on the grid, it's because I want to make sure I'm recreating the test case with the same numbers. It just makes it easier for me to see what's going on. What? 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 Why? Number 1, number 2, number 3, number 4. Number 1, 2, 3, 4. What? Wait, do I have 2 printouts? Oh yeah, I still have these laying around. Okay. in a weird way, I'm kind of glad that I'm debugging because I don't know if I have the mental capacity to write new code today. How is this possible? How can it be that doing for v equals all n list, it just runs once for 129, and then immediately after it, it runs the loop 4 times for these 4 just bizarre numbers out of left field? Like, is it something about how, like, the variable is misspelled? Oh. Maybe it has to do with this. I wonder if that will... I think I had a name collision. Maybe not. What? What? How does this make any sense at all? I don't understand. How is this even possible? How can this call to for v and all n list give different results to this call for... I mean... There's no way this is a bug. Oh man, now I've really gone and done it here. Oh, when I say there's no way it's a bug, I mean there's no way it's a bug in Pico 8. I don't understand how this is possible. What's going on? The only thing that I know of that could cause this is if the variable is being edited inside the for loop. Actually, I better keep that. I just wanted to get rid of these do it agains. What? Oh, wait, no, never mind. No, yeah, we're still having the same problem. My end list has just 129. And then when I do for all, for V and all, I do that. I don't. So here, I'll show you. Like, let me just make sure here. The problems start here. My end list has just one thing in it. How is that second for loop? Running so many times. Alright, I got another idea. What? How did it change? What? What? It suddenly became equal to the... Somehow, between here and here, my end lists just randomly started pointing to neighbors. This is ridiculous. I mean, is this a bug in Pico 8? I'm starting to wonder. My end list of 1. So DFS at 390. We did it for all, it was fine. We did the KV loop, it was fine. On the first iteration, everything's fine. Actually, I wonder if that was true last time and I just didn't notice, because this printout is a little hard to read. So actually, it gets messed up by the time we get to the second iteration. Okay, that's progress, at least. So something happened in this for loop. If not seen, let's assume we go in here. I think we do. If it's equal to the net, then we do that. I don't think that's happening. If it's a component, that is not happening. If it is a junction, which it is, we do, oh no. No, wait a minute. No, we look down, so nothing's in there actually. So we look down, nothing, that doesn't happen, that doesn't happen. Else, seen if an L equals true, end. So far it's correct. Then we get into the first iteration. So far it's correct. We get to the nothing to see here case, and then somehow it's messed up. I don't understand how this is possible unless there's a bug in Pico 8. What time is it? Oh no, I need to go. Damn. Shoot. I really gotta go. I'm late. Well, I'm not late. It's a self-imposed time, but in other words, no one's waiting for me, but let me just do this one last test here. This won't help me solve it, but it'll give me information. Or, sorry, I should say this won't solve it, but it'll give me information that should help solve it. So somehow, my end list, that variable, is getting rebound to something else? How is that possible? I really need to go. I really need to go. I think this is a bug in Pico 8, which is this is the very, very, very first time I've ever seen a bug in Pico 8 in all the time I've been using it. Okay, let's get rid of some of these extra printouts. I really need to go, or else I'm gonna be frustrated. But like, now I'm hooked on trying to solve this thing. Let's see if this also causes the error case. Let's just do it properly. Endless is nil. Is this some issue with the garbage collector? And it just so happens that in this exact test case, I happen to trigger a garbage collect at exactly the right time to hit this. This really smells like well, it smells like garbage. Ha ha ha. No, it really smells like the garbage collector. Okay, this is not something I can do right now. I really need to go, which is really frustrating. Oh well.